last two talks, we built the conceptual framework for evaluating evidence: internal validity, external validity, bias, confounding, sampling, and the evidence hierarchy. Now we get practical. How do you actually sit down with a paper and systematically evaluate whether it's worth believing and applying? Critical appraisal is a structured process of evaluating a study's methods, results, and conclusions against explicit quality criteria. It's not skepticism for its own sake. It's the discipline of asking the right questions in the right order so that you can make informed judgments about evidence quality. In this talk, we'll walk through a systematic appraisal framework, introduce the major reporting guidelines that structure how good papers should be written, STROBE for observational studies, CONSORT for clinical trials, and REFLECT specifically for veterinary trials, and cover one of the most important and frequently misunderstood concepts in clinical trial analysis: intention to treat versus per protocol analysis. Let's go. Let me make the case for why critical appraisal is a non-negotiable clinical skill, not just an academic exercise. Peer review is imperfect. Reviewers are volunteers working under time pressure, often without access to raw data. Studies with serious methodological flaws, inadequate power, uncontrolled confounding, inappropriate statistical tests, selective reporting of outcomes, get published regularly in reputable journals. The presence of a paper in a peer-reviewed journal tells you it passed a quality threshold, not that it's free of important limitations. The reproducibility crisis is real. A substantial proportion of published findings in medicine and biology fail to replicate when independent groups attempt to reproduce them. The causes are multiple: small sample sizes generating inflated effect sizes, publication bias toward positive results, flexible analysis choices, and genuine sampling variation. A simple positive study, even a well-designed one, is rarely sufficient to change clinical practice. Marketing materials and conference abstracts are not substitutes for full papers. They selectively highlight favorable results, omit methodological details, and present preliminary or post hoc findings as if they were primary outcomes. But critical appraisal is not nihilism. The goal is not to reject all evidence, it's to calibrate your confidence appropriately. Some studies deserve high confidence and should change practice. Others provide useful but uncertain evidence that informs practice without dictating it. Others should be set aside as too flawed to be informative. Critical appraisal is the skill that lets you make those distinctions efficiently and consistently. The three-question framework is the foundation of critical appraisal, and it applies to every study design. The questions are sequential. You don't move to question 2 until you're satisfied enough with question 1 to proceed, and you don't move to question 3 until you have a clear answer to question 2. Question 1. Are the results valid? This is the internal validity assessment we covered in Talk 5.2. Was the design appropriate for the question? A cross-sectional study can't establish temporality. Don't let authors claim causal conclusions from cross-sectional data. Was the sample size adequate? Did the authors report a power calculation? Were important biases avoided? Were outcome assessors blinded? Were exposed and unexposed groups comparable at baseline? Was confounding measured and controlled? These questions map directly onto the threats to internal validity we've been building throughout this series. Question 2. What are the results? Don't stop at whether the p-value is below 0.05. Look at the effect size. Is it large enough to be clinically meaningful? Look at the confidence interval. Is the estimate precise? Or are the bounds so wide that the true effect could be trivial or enormous? If the CI includes the null value, what does the lower bound tell you about the minimal plausible effect? Question 3. Are the results applicable? This is the external validity assessment from Talk 5.2. Your patient, your setting, your resources. The 7-step framework from Talk 5.2 maps onto this question. Universal questions. Each study design has specific appraisal questions that reflect its particular vulnerabilities. For randomized controlled trials, Randomization must be truly random, not just arbitrary, and allocation must be concealed so that the person enrolling animals doesn't know which group the next animal will be assigned to. Lack of allocation concealment allows conscious or unconscious manipulation of who gets enrolled into which group, blinding of the animal owner, the treating clinician, and especially the outcome assessor prevents observer bias. Complete and equal follow-up is essential. Differential dropout between groups is a red flag for selection bias. For cohort studies, were the exposed and unexposed groups truly comparable at baseline? Any systematic difference in baseline characteristics other than the exposure is potentially confounding. Was follow-up long enough to observe the outcome of interest? A 30-day follow-up for a disease that typically takes 6 months to develop will miss most cases. And was loss to follow-up similar between groups? If one group had more dropouts and the dropouts were systematically sicker or healthier, the results are biased. For case control studies, were cases and controls drawn from the same source population? If cases come from a referral hospital and controls from a primary care clinic, Bergson's bias is operating. Was exposure assessment blinded to case status? If the interviewer knows who the cases are, differential probing for exposure history can create recall bias. Was every effort made to minimize recall bias through objective records or validated instruments? For cross-sectional studies, was the sample truly representative? Or was it a convenience sample with systematic differences from the target population? And critically, can the causal direction be established? In a cross-sectional study measuring both exposure and outcome at the same time, it's often impossible to determine whether the exposure preceded the outcome or vice versa. Reverse causality, where the disease caused the exposure rather than the exposure causing the disease, is always a possibility. Guidelines exist because a study that isn't fully reported can't be fully appraised. If an author doesn't tell you how they randomized animals, you can't evaluate whether randomization was adequate. If they don't report how many animals were lost to follow-up, you can't assess whether attrition bias is a problem. Reporting guidelines are the minimum reporting standards that make appraisal possible. STROBE, strengthening the reporting of observational studies in epidemiology, is the standard for cohort, case control, and cross-sectional studies. It covers 22 items across domains including study design and setting, participant selection, variable definitions, sources of bias, statistical methods, and limitations. A STROBE-compliant paper gives you everything you need to evaluate its internal and external validity. CONSORT, Consolidated Standards of Reporting Trials, is the standard for randomized controlled trials. Its 25-item checklist covers the full trial life cycle from randomization to reporting, including the critical items of allocation concealment, blinding, participant flow through each stage, the CONSORT flow diagram, losses and exclusions, and the intention to treat analysis. REFLECT, Reporting Guidelines for Randomized Controlled Trials in Livestock and Food Safety, is a veterinary-specific adaptation of CONSORT developed to address the unique features of veterinary trials: animal species and breeds, production systems, herd level versus individual level outcomes, animal welfare considerations, and the regulatory context of food animal medicine. REFLECT is the standard to apply when critically appraising veterinary RCTs, particularly in food animal and production medicine contexts. When you're reading a paper and something feels incomplete, you can't figure out how they allocated animals, or they don't tell you how many were lost to follow-up, reach for the relevant reporting guideline checklist. Missing items are not automatic disqualifiers, but they limit your ability to evaluate the study, and that uncertainty should reduce your confidence in the findings. To treat analysis is one of the most important and most frequently misunderstood concepts in clinical trial reporting. It's also explicitly required by CONSORT and REFLECT, which is why it belongs in this talk. The principle of ITT is straightforward. Analyze every participant in the group they were randomly assigned to, regardless of whether they actually received the treatment, completed the protocol, or crossed over to the other group. This means if a dog was randomized to the treatment group, but the owner never gave the medication, the dog is still analyzed as a treatment animal. If an animal was randomized to the control group and accidentally received the treatment, it's still analyzed as a control. Why? Because the benefit of randomization is that it distributes confounders equally between groups. The moment you start excluding animals from the analysis based on what happened after randomization, dropout, noncompliance, crossover, you break the randomization and reintroduce the possibility of confounding. Non-completers in a treatment group are not random. They're often the animals who couldn't tolerate the treatment because of adverse effects, or the sickest animals whose owners withdrew them. If you exclude them and analyze only completers, your treatment group becomes a selected, healthier than average sample. Your efficacy estimate is inflated. ITT is conservative. It typically dilutes the apparent treatment effect because some treatment animals didn't actually receive treatment. This is intentional. It gives you the real world effectiveness, what happens when you offer this treatment to a population that may not comply perfectly. Per protocol analysis, analyzing only animals that completed the protocol as assigned can give you useful information about biological efficacy under ideal conditions, but it must be clearly labeled as a secondary exploratory analysis, not the primary result, because it is susceptible to the very confounding that randomization was designed to prevent. When reading a trial, if the primary analysis is per protocol rather than ITT, or if the authors don't specify, flag it. Ask yourself, who are the missing animals and how would including them change the result? Before we close, I want to introduce one more concept that shapes how you should interpret the published literature as a whole: publication bias. Publication bias is a systematic tendency for studies with statistically significant positive results to be published, while studies with null or negative results languish in file drawers or never get submitted. This is not necessarily a matter of fraud. It reflects the incentive structure of science. Journals prefer novel, significant findings. Authors know this and may not bother submitting a null result. Reviewers may look more critically at a null result, wondering whether the study was just underpowered. The consequences are real and well documented. The published literature for many treatments overestimates efficacy because the positive trials got published and the negative ones didn't. When you do a meta-analysis of the published literature and pull results, you're pulling a biased sample. The famous example from human medicine. Antidepressant trials submitted to the FDA showed a much less impressive effect than the published literature suggested, because the FDA saw all the negative trials that were never published. The funnel plot is the standard tool for detecting publication bias in meta-analyses. In a symmetric funnel, small studies scatter widely around the pooled estimate because they're imprecise, and large studies cluster tightly near the truth. If the funnel is asymmetric, particularly if small studies with negative results are systematically absent from the lower left quadrant, publication bias is likely. Trial registries are the structural solution. Pre-registering a trial before data collection, specifying the primary outcome in advance, and committing to public reporting of results regardless of direction. When reading a meta-analysis, check whether the included trials were registered and whether any registered trials are missing from the published record. The practical clinical implication: for any treatment where the evidence base consists primarily of small positive trials and no published negative trials, Your confidence should be tempered by the suspicion that the file drawer is not empty. Summary. Critical appraisal is a structured process of evaluating a study's methods against its conclusions. The three core questions, valid, results applicable, provide a universal framework. Design-specific questions target the particular vulnerabilities of RCTs, cohort studies, case control studies, and cross-sectional studies. STROBE, CONSORT, and REFLECT are the reporting standards for observational studies, RCTs, and veterinary trials respectively. Use them both as a reader and as an author. ITT analysis is required for confirmatory trials because it preserves the randomization that controls confounding. Per protocol analysis is exploratory only, and publication bias inflates the apparent efficacy of treatments in the published literature. Recognize it, look for it, and temper your confidence accordingly. That completes Talk 5.3. In the final talk of Unit 5, Talk 5.4, we cover sample size and statistical power as a study design concept, linking the statistical foundations from Talk 3.4 to the appraisal skills we've just built. The video, read the scenario, and try to work through the questions on your own. We'll then go through the answers together. This scenario is carefully constructed around a realistic and very common problem in the veterinary clinical trial literature. Small RCTs that use per protocol rather than ITT analysis report statistically significant but clinically small effects and get cited as evidence for nutraceutical or supplement use. Question 1. Reporting guideline and missing items. The applicable guideline is CONSORT. This is a randomized controlled trial. Since it involves companion animals, REFLECT would be the more specific veterinary adaptation. 3 items you cannot evaluate without the full methods section. Randomization method, was it truly random or quasi-random? Allocation concealment, did the person enrolling dogs know the next assignment? And blinding, were dog owners, clinicians, and outcome assessors blinded? Question 2, per protocol as primary analysis. The 9 dogs who withdrew from the treatment group are not a random subset. They are systematically different from the completers. 5 withdrew due to GI side effects, 4 due to owner noncompliance. The per protocol analysis compares a selected systematically healthier, more compliant treatment subgroup to a less selected control group. The result is biased away from the null. The supplement appears more effective than it truly is. Question 3, ITT population. Treatment group, 40 dogs. Control group, 40 dogs. Total, 80 dogs as originally randomized. Handling missing data options include last observation carried forward, multiple imputation, or worst case imputation as a sensitivity analysis. Question 4, 3 caveats. First, per protocol analysis likely inflates the effect and the true ITT effect may be smaller or non-significant. Second, clinical significance is questionable. A mean difference of 0.8 points on a 0 to 10 scale may be below the minimum clinically important difference. Third, publication bias and study size concerns. This is a single small trial, and the supplement industry funds many small positive trials while rarely publishing negative ones.